In this video, we're going to talk about solving absolute value inequalities of the form greater than or equal to. So let's take a look at the absolute value of x is greater than 3. Well, let's draw a number line to figure out what value specifically will work here. Well, 3 and negative 3 do not work, but they're boundary values. So what values will work? Well, let's try 4. Well, the absolute value of 4 is 4, and 4 is greater than 3. 5 works because the absolute value of 5 is 5, and 5 is greater than 3. So values greater than 3 would work here. Are there any other values? Well, how about negative 4? Well, the absolute value of negative 4 is 4, and 4 is greater than 3. Negative 5. Well, the absolute value of negative 5 is 5, and 5 is greater than 3. So values less than 3 work also. So either x is greater than 3 or x is less than negative 3. And I can write that in interval notation. So when the absolute value bars are by themselves, and when I have either greater than or equal to, that is an or statement or a union. So let's write this out in general. If the absolute value of ax plus b is greater than or equal to c, then ax plus b is greater than or equal to c, or ax plus b is less than or equal to negative c. Okay, so let's solve the absolute value inequality and then write the final answer in interval notation. Well, I need to get the absolute value bars by themselves, so I'm going to add 2 first. Now, the absolute value bars are by themselves, and it's greater than or equal to, so it's an or statement. So let's write out our 2 inequalities. And now we're going to solve each inequality. Okay, so let's graph. I'll start with x is greater than or equal to 22/3. Now remember, it's an or statement, so it does not have to be in both. So I'm going to start on the left-hand side. That's negative infinity to negative 6. Because negative 6 is a solution here, it's a solution to the union. Now, because they are disjointed, meaning that there is no intersection, I need to put a u there for the union. And I go from 22/3 to infinity. And because 22/3 is included here, it's included on our final answer also. Okay, let's take a look at the next example. Again, the absolute value bars must be by themselves, so I got to get them. So I'm going to subtract the 7 first. And now I'm going to divide by a negative 3. Now remember, when you divide by a negative number, you must switch the inequality sign. Now notice, the absolute value bars are by themselves, and it's greater than. That means it is an or statement. So write out the 2 inequalities. Subtract 2. Subtract 2. Okay, so now let's graph. I'll start with x is greater than 5. Now x is less than negative 9. Now remember, it's an or statement. It could be in one or the other. So let's start from the left. Negative infinity to negative 9. Because negative 9 is not a solution here, it is not a solution to the union. Again, because they're disjointed and it's an or statement, I need to have the u there. 5 to infinity. And again, because the 5 is not included here, it's not included in my union either. Okay, one other example. Now again, the absolute value bars are already by themselves and it's greater than or equal to. So it's an or statement. So let's write it out. Okay, so solve each inequality. Okay, so let's graph. So we'll start with x is greater than or equal to 1/3. Underneath will be x is less than or equal to 7/3. Now, notice here this is not a disjointed set. They do have something in common. So now, if I combine this line with this line, what do I have? Well, I have everything, right? So here my solution is negative infinity to positive infinity, meaning any real number that I plug in for x will make this inequality a true statement. Now, why is that the case? Well, we talked about in the last video, when we talk about absolute value, it's a distance, meaning that it's either going to be 0 or positive. So 0 and positive numbers are always going to be greater than or equal to -3. So it makes sense algebraically that we have infinitely many solutions, or in this case, all real numbers. In other words, writing that from negative infinity to infinity.